Good evening, everyone. Welcome to the Faculty Development Program under ATAL Academy. Today is the third day of our Faculty Development Program, and today we have two eminent speakers from academia as well as industry. As we all know that there are so many security issues in healthcare data or medical data, and in that case, security as well as privacy issues is the main concern, even in the cyber security perspective. So today, the first session will be delivered by Dr. Mohd, and her topic is security and privacy issues in the healthcare sector. Dr. Mohd is an associate professor in the Department of Computer Application, National Institute of Technology, Raipur, India. She has more than 13 years of teaching and research experience. She has obtained her PhD from Indian Institute of Technology, ISM Dhanbad. Vehicular Adult Network, she has supervised 3 PhD candidates and at present supervising 5 PhD candidates under her sole supervision. She has received a grant of 20 lakhs as principal investigator and 30 lakhs as OPI. Government of India. She has published more than 70 research papers in SCI indexed international journals, international conference, book chapters, and delivered more than 20 keynote lectures or expert talks in several international and national conferences, workshops, seminars, faculty development programs, short-term courses. She has acted as the member of advisory committee, technical committee, program committee, session chairs in several international national conferences, seminars, workshops. She is a reviewer of various international and national journals published by IEEE, SpinJar, Elsevier, Wiley, CSI, IIT, MDPI, and Harvard. She is a fellow member of IIT, senior member of IEEE, and life member of ISCA, IAENG, ISESIT, and CSE. And I hope this session will be very much interesting, and this is my request to all the participants. Please interact and try to engage actively in the testing. Now, I would like to welcome Dr. Mo Dasgupta to start her session. Over to you, madam.
Am I audible? Hello, am I audible? Hello, am I audible? Okay.
Yes, madam.
Yes.
Okay. Thanks. First of all, I thank the organizer for conducting such informative faculty development program. So I would like to share my screen now. Screen visible?
You're audible, madam.
Yeah, I'm audible, but are you able to see me?
I think there is a network issue because your audio is not clear.
Audio is not
Now
clear.
it is opening.
Okay, it's opening.
Yes.
Okay, let me. You can't share your screen. Error occurred. Just a minute. Yeah. Is the screen visible now?
No, ma'am.
Okay.
No, ma'am.
Now it is visible, madam.
Okay, fine. Okay. Just let me check another thing. Is the slides moving?
Yes. Yeah.
Okay, thank you. Okay. So the title of my presentation is Security and Privacy Issues in the Healthcare Sector. Okay, I think for the past couple of sessions, you were already being informed about some of the security and privacy related techniques. So today in my presentation, I would like to share with you people how this healthcare sector is first of all being benefited with our the advanced technologies that is called Internet of Things, and how this advanced technology has some of the security problems and how it can be solved. So all these things will be covered up in this presentation. Fine. So as I said just now that with the very advanced technology that is called Internet of Things or IoT in short, so our healthcare sector is very much beneficial when we are using this technology, because what happens in the traditional health sector is that normally suppose I am a patient, so I visit the doctor physically, and then I share my problems with the doctor, and then as per the doctor's suggestion and prescription, I go on to buy the medicines or I go on for some of the tests. Then I return back to the doctor. So this is the traditional healthcare service that the doctors provide to the patients. Some of yours mic is on. So after the introduction of this advanced technology, what happens? I may not go to the physician physically. So what happens? It monitors with the help of this technology. My vital stats can be monitored by the doctors in the real time. So how how it works, I'll explain it in the later slides. So first of all, we just make sure that we understand the concept that how IoT is beneficial for the patients. So what happens in case of the patients, there are some of the wearable devices, like we have the BP monitoring cuffs, like we have some of other means wristbands type of things. These devices are being worn by the patient, and these devices collect the vital statistics from the patient's body. So they are all connected by using the wireless body area network. So when this data is being collected in a system, so it gives a more means alert type of thing to the patient. Suppose I'm not exactly in such a serious patient to go to doctor right now, but somehow my doctor has prescribed me to check your blood pressure at frequent intervals. So what happens if I wear or at some time interval, it will monitor my blood pressure, or it will give me some of the alert messages when my BP fluctuates. So in that manner, I will be more I'll pay attention to my blood pressure rather than measuring in the traditional blood pressure machines. So like this way, all the vital statistics can be monitored, and the patients become more informative if they use this type of IoT devices. So this is the patient part, means for the IoT, if they use IoT in their application. So likewise, when we talk about the doctors or the physicians, so what happens when these data that are being collected from the patient's body through these IoT devices, so they are sent to the physicians, means not only the doctors, to nurse or other healthcare service providers in the real time. So they can means they actually they get much more information from those data. So other than what happens in a traditional scenario, when I visit the doctor, I usually they ask me what is the problem, right? So I explain in my own way. So in the morning I felt like that, in the evening I felt like that, and so on. And based on that, he may advise some tests to be performed, or he may write some of the medicines in the prescription. But when he has the actual data of my means vital statistics, he actually get that data, then he becomes more concerned, and he exactly knows what is going on in my body. So that becomes very much beneficial when he gives any treatment plan to me. So likewise, it is much more means informative. Very much the doctors can make the decisions more accurately based on those data that are being captured from my body. So physicians are actually being helping, or they are being proactively providing the medical service to the who are living alone in their home, like in the Western countries. So what happens? The real-time data is being fetched by the physicians, and the alert messages are being sent to the physicians in case of emergency, so they can take the right decision on such situations. So IoT is also very much helpful for the hospitals. Like what happened in the hospitals, some of the places. So there requires a management for this, that which to be by using Internet of Things technology. And one more thing in the hospitals is that the means concern of infection is very much important in case of hospitals. And I also faced the same problem a few months back. What happened when I was actually in the hospital for some of my, for my relatives. So what happened there, all of a sudden when I was in room ward, so I informed all the parents and the relatives for the room that please we have to disinfected it. So we asked how it is possible. There is some technology and some sensors there. So actually detected that this room
Ma'am,
is it has
ma'am,
got
sorry to
infected.
interrupt. Ma'am, the PPT is not visible.
PPT is not visible now.
And now it is visible.
It's visible.
Yes, ma'am, now it is
Not,
visible.
but not movement.
No, again, it is not visible.
Changing the slide. I am not changing the slide. I have not. I have just changed the slide once. Are you which slide are you watching here? The title slide
Healthcare
or
and
the
IoT.
first slide?
Healthcare and
Healthcare and IoT.
IoT.
I'm in this slide only. I'm in this slide only. I'm explaining this slide points only.
Now it is
Is there any
visible,
other
ma'am.
confusion? Okay.
Now it is visible.
Okay. So this slide was not visible earlier. Okay. So what is the
Actually,
problem then?
the slide is not changing. That's why I think you are
No, I
participating.
have not finished. I have not finished. Done with the
Okay,
slide.
madam.
Okay, I'm just explaining the points.
And then it's
Just
okay,
pay
madam.
attention to the points. I am now talking for the point number 3, IoT for hospitals. I'm talking about how IoT is helpful to the hospitals. Okay. Earlier, I explained 2 points: how IoT is helpful to patients and how IoT is helpful to the physicians. Okay. So what happens in the hospitals when this technology, when they use, hospitals use this technology, they get the information about any room, whether it is infected or not. And they can take decisions appropriately. They can also manage the equipments like the oxygen cylinders, the nebulizers, and all those equipments that are to be relocated in the real time, and also the relocation of the medical staffs in real time. This can be done by the help of IoT applications. Fine, in the health sector. Now, again, IoT is helpful for the health insurance companies. So I'm talking about the 4 aspects of the health sector where IoT, when applied, can be beneficial to them. Okay, so in the health, for the health insurance companies, what happens? They can take the data, the real-time data, and they can verify when the patient comes to the company and he or she claims. Then the health insurance companies, they actually verify the data that they have already taken from the IoT devices. So in this case, the settlement of the claim procedure becomes very transparent. So IoT is also helpful to the insurance companies as well. So these are the 4 aspects of a health sector where IoT can be helpful. So how, see, with the help of this technology, IoT technology, we can change the scenario of the traditional health sector into a more advanced one and at the ease of the patients. Now here, the first and the foremost thing is that the patient did not visit the hospital or the doctor physically every time. So this is the most advantageous thing. So in the seconds now, I will talk about how these things are being organized. So here it has 4 steps rather. So in the first step, all the devices that I talked for the patients, IoT for patients, so all those interconnected devices are first deployed. Okay, so this deployment is done as the step 1. And in the step 2, these data, when these devices collect the data, they are actually in the analog form. So this data needs to be converted to the digital form and they need to be aggregated. So this thing is done in the step 3. And in step 4, after the digitization and aggregation, the data is pre-processed into some standard format, and they are now moved to the data center or the cloud. So this is done in the step 3, and finally in the cloud, some analysis is made where the decisions are being given at the required level. So these are the 4 stages or steps to how in healthcare sector or in any other IT application the things are done. Okay, so this is just shown in this figure, the 4 stages. And talking about the advantages, already I told about the advantages of IoT in healthcare sector. So the first thing is that the cost reduction. See, first of all, I need not visit the doctor or hospital every time physically. So it reduces the cost in many aspects. I did not travel a lot for this. So this reduction, and 2 more important things are there. If we use IoT in healthcare sector, then the cases of readmission becomes very less. It has actually decreased the cases of readmission. Okay, and the number of hospital stay also, because in the traditional conventional health scenario, what happens? The doctors won't rely on other factor, and he or she will, the hospitals will keep you for a number of days more than the required number of days to watch that whether the patient is actually getting better or not. But if this technology is being used, it can be the doctors can monitor from the remotely also. So in this case, the number of hospital stay period becomes less, and also the cases of readmission becomes less. So in this manner, the cost is reduced. Now, the improved treatment by the physician, they are getting all the so the very much means they get the means actual information with the help of those data, rather than from the patient what they are saying about their health. So they can stick to a more accurate treatment. Means they can adhere to the plans, and they can also see whether the patients are adhering to the treatment plans accurately or not. So treatment gets improved in this manner. Faster disease diagnosis, because they are actually doing the real time monitoring, so any diagnosis can be detected earlier. So that is another advantage. So we also get proactive treatment, because something happens and then we rectify it, rather than the doctors can, as they can diagnose earlier. So the proactive treatment is also possible, which is the other aspect of that. And finally, the drugs and the equipment management is also done by getting the real-time data in the health scenario. So these are the advantages. Now, you may think that why I'm talking about IoT here, because in the traditional scenario, that the physical visit and the physical means face-to-face talking with the doctors, the patients, whatever their service they're getting, that is being solved when they use telemedicine scenario. But in the telemedicine scenario, the exact data is not being provided to the physicians. That is the advantage for using IoT rather than the telemedicine scenario. Okay. So now this is the scenario that I have already placed. This is the summary. Actually, I have mentioned in short how IoT can be implemented in healthcare. Later, I'll show some of the application also in this presentation. But what comes next is that whenever the patient's data is being transferred from the patient side to the doctors or hospital side, so this data is being traversing through network, right? Computer networks or networks. So there is a medium. So when the data is traversed from the sender to the receiver, it can be changed, or the data can be fetched by some other people. Okay, so that is not a desirable scenario. Data is a sensitive data. So I don't want medical be revealed to the doctors. Okay, so this is a privacy concern, because I want my data to be private. This is privacy. And I also want my data to be secure. That I do not want a third person data. Security. I want my medical data to be private and secure. So this is the means this is very much important in this scenario when I'm using IoT in to get the health service. Because if my data is being modified and if it is done intentionally, then many things can happen. It may happen that an elderly is living alone in a home. And in case of emergency, rather than giving the right data to the doctors, the data is being manipulated by some relative only. He or she can do so. Then he will not get the desired treatment in that case. Okay, so here comes the concern of how this medical data can be secured. And privacy, it comes along. Because privacy is that I just do not want my data to be revealed to anyone. He or she may not harm, may not change my data, but I just don't want it. Okay, that is another issue. And the thing is that why I would allow someone to modify it. If he or she can read my data, he or she may be able to modify it. So we have to make this scenario secured one. So for this, we need security techniques. And the most common version of data security is the public key encryption. So this is the basic one, where what we have in this health scenario only, what we have a say center, let us call it KGC, that is it is providing some key, it is generating some keys. So this center is a trusted center. Now what happens, this center will provide me a key. So likewise, if there are n number of users, so it will provide the keys to the n number of users. Now it will provide a pair of key rather than providing a key. One is called a public key and another is called a secret key. Okay, so what will happen when I want my data to be available to the doctors? So I have to send it to this doctor by encrypting this data. So how would I encrypt? I would use the public key that has been given by the center KGC to me. So I'll use this public key and encrypt my data, medical data, and it will then convert into some other form that is called ciphertext, and then this particular encrypted data can be sent over the insecure channel or the open channel or the public channel. So now what happens if anyone fetches the data, since it is in the encrypted form, he or she cannot actually read the content. Or if he or she cannot read the content, then most probably he or she won't be able to modify it. So now the thing that comes to the doctor's side or the hospital side is that the doctor or hospital needs to decrypt this data to get the actual original message. So when I have encrypted this data with the public key of the doctor, so the doctor has his own secret key. So his secret key will be used to decrypt the data. So this is how encryption and decryption takes place. So everyone has a public key and a secret key pair that is being given by the key generation center. And whenever one wants to send the data, he or she has to encrypt the data with the sender's public key. The corresponding secret key will be used to decrypt the data. Okay, so this is now how I have made my data secured. But what happens in this scenario when this n becomes very large, means the users become very large, then this center gets overloaded. Okay, now this center has to provide this factorial n, means this much amount of keys are to be managed by the center now. So it gets very difficult when the users are increased. Okay, so what happens now? The next solution comes to this is that if we can use something where the public key need not be generated by the center. So here comes the concept of identity. So every user has a unique identity of him or her. So this unique identity becomes the public key of the user here. So this technique is called identity-based encryption. And here, instead of generating the public key by the center, the user has to provide one unique identity. This identity could be anything. It could be any biometric. It could be any unique ID like the Aadhaar card. Okay, any unique thing should be there that is to be provided by the user to the center. And based on that identity and with some other parameters, the key generation center provides the secret key of the user. So here the ID, the unique identity becomes the public key and the secret key is only being generated by the key center. So the load of the key generation center gets reduced in this case. And the encryption and decryption is done using the same methodology. The ID now becomes a public key, which is used by the patient to encrypt his medical data, and the decryptor has its own secret key, so by it can decrypt the data. Okay, but what happens in this both scenario, in the identity-based encryption and also in the earlier one, they both are having one-to-one correspondence. So one-to-one correspondence means one user, and obviously the center has to provide one pair of key for them. Okay, so the encryptor has to encrypt the message, the sender has to encrypt the message, and only one receiver can decrypt the message. So this is the one-to-one correspondence that is prevailing in these two cases. So the next solution especially for health sector is the attribute-based encryption. So what happens in this case in attribute-based encryption is that the first and the foremost advantage that we have if we use attribute-based encryption is that here we may have one sender, suppose I'm the patient, so I will encrypt my data, but since it is a health sector, so it is not mandatory that only one doctor will be able to decrypt my data, because I want, in case of emergency, I just want my data to be reached to the hospital, and whoever doctor is present there or whoever medical staff is present there, he or she should be able to decrypt the data, and he or she should provide me the medical assistance immediately. So this is what I want. So here one-to-one correspondence is not sufficient. I want a group of decryptors here rather than only one decryptor. So for this reason, this particular attribute-based encryption mechanism is used in the health sector for providing security rather than the earlier two ones, the public key encryption or the identity-based encryption. Because in that case, only one person will be able to decrypt. But here, a group of people will be allowed to decrypt the data. So what happens in this case, I have used a health sector example. Suppose we have a hospital, and that hospital has the departments like ortho, cardio, pulmonary, etc. Okay. Now, obviously, in every department, there are the medical staff. So some of the medical staff might be the surgeons. Some of the medical staffs might be the MD doctors. Some of them might be nurses, and so on. So these are the designations of the medical staffs and the departments. So these are the attributes that I'm calling here. Okay, so this attributes, based on these attributes, a particular person will have his or her own credentials. Like in L here, what is happening? This particular user is having the credential cardio and surgeon. That means this particular person belongs to the cardio department and he or she is a surgeon. So every user will have his or her own credential based on the attributes. Okay, so attributes are well defined for a particular hospital, and then depending on the attributes, all the medical staffs, all the persons or users are having their own credentials. So now what the user will do? The user will provide the credentials to the key generation center. And the key generation center, based on that credential of the user, along with some other parameters, public parameters and master secret key, I'll come to this later. So along with other parameters, this key generation center will provide the secret key corresponding to that credential, SK_L, to the user. Okay, so now here the secret key belongs to the credential of the users. Now what happens? Rather in the earlier cases, the sender or the patient in our example, what he or she used to do, he or she used to encrypt the data by using the public key of the doctor. Now here, the encryption is done in some other manner. Here, we have some policies. Okay, so this capital W, this is the policy that is being used in this example. So this policy states that the person who should belong to the cardio department and who should be either surgeon or MD. Okay, so this is the policy that I'm providing, that this person should be means encryption will be done based on this policy here. So this policy is decided means it is decided when the application is actually set up. So this, based on this policy, the encryption of my data is being done. Okay, rather than using any public key. So this policy is used for encrypting the data, and it becomes a ciphertext that is being sent to the hospital here now. Now we have a group of decryptors. So every user is having his or her own credentials. Like here, I have used 3 such users with 3 credentials. The first one is cardio and nurse. Second one is cardio and MD. Third is ortho and MD. Now, who should be able to decrypt the data? Okay, the thing is that whoever is now satisfying this policy, the user that is satisfying this policy is now will be able to decrypt the data. So let us see whether user 1 will be able to decrypt the data or not. First one is cardio, it is satisfying, but cardio and surgeon or MD. So the second attribute is nurse. So user 1 won't be able to decrypt the data here. User 2 will be able to decrypt the data because the credentials that user 2 is having is satisfying the policy, cardio and MD. So user 2 is satisfying the policy. So user 2 will be able to decrypt the data. Again, user 3 is not satisfying the policy. So user 3 won't be able to decrypt the data. So in this manner, I have encrypted my data based on this policy, and it has been sent to a group of decryptors, group of people. They are getting the data, but only the intended data, that is, means who will satisfy the policy will be able to decrypt the data. Okay, so this is how attribute-based encryption works, and it is very much useful in case of health sector. Now, formally defining attribute-based encryption, it is also a type of public key encryption technique because we are using 2 things, one for encryption, another for decryption. So what happens here? The message is encrypted for a group of decryptors or multiple users. Now, these users should possess a certain set of attributes. Okay. Now, the user's role is here described by the set of attributes that they possess. And the secret key of the users and also the ciphertext, they depend upon the attributes. Whatever attributes we are having for our application, that attributes are ultimately used for generating the ciphertext and the secret keys. So decryption of the ciphertext is possible when the set of attributes of the user key, it matches the attributes of the ciphertext. And otherwise, the decryption is not possible in this case. Now, AB is very much beneficial, or we can say that it is very effective mechanism in the cloud environment, because most of the applications of cloud, they supports one-to-many communication. And in healthcare sector, as I said earlier, that it is very much promising because we cannot do other than one-to-many communication here in our health services, getting the health services. And what happens in cases of RSA and other public key encryption techniques is that the overhead of the maintaining keys, infrastructure, public key infrastructure, like the digital certificates are required, and how we can manage all those keys, that things require a lot of overhead. So this overhead is avoided if we use attribute-based encryption. And for identity-based encryption, which also overcomes this overhead of RSA, but what happens, it does not supports one-to-many communications. So IB cannot be used in this case. So our only option here is that to use attribute-based encryption. Now, for using this mechanism, we need the access policy. What policy means, it actually gives you the authorization or the access control of the user. So what is this access policy? We need to formally define what access policy should be and how we can generate those policies. Means what are the rules for generating or developing those policies. So the policy is used to have the access control over the encrypted data. So it actually implies that that the user that can means who can access the encrypted data that is given by this policy. So it is used or it is constructed by using the access structure, which is again defined mathematically, which is denoted by capital gamma. And access structure is defined as a set of n attributes. Let us say that A1 through AN are the set of n attributes. So the access structure for this n number of attributes is defined as a monotonic collection of non-empty subsets of these attributes A1 through AN, which is denoted by 2 to the power A1 through AN. Okay, and since it is a non-empty subset, so we have to use the null set. We should not include it. So gamma is a subset of 2 to the power A1 through AN minus null set. Now, all the attributes that are included means in this set at access structure are called authorized attribute sets. And the attributes that are not included in the access structure gamma, they are called unauthorized attribute set. So this access structure is again represented by using the access trees. So access tree is like any other tree in computer science, which has leaf and non-leaf nodes. So all the non-leaf nodes, they use the gates, the concept of gates, AND gates or OR gates, although any other combination is also possible. So, but major applications or major schemes that we use for ABE, they use the and OR gates only. So for AND gates, it is represented by using 2 of 2. And for OR gates, it is used 1 of 2 threshold gates. Okay, so let us define this, how we can use these things here. So let us say that capital T is the access tree that represents our access structure gamma, capital gamma. And some of the notations that I will be using later on is these are the notations like num of x, which implies the number of children node X has. Attribute means ATTRX, which implies the attributes that node X has, and parent, who is the parent of node X, and index is also another term that will be used here for node X, and the threshold value TH of X, THX. So every non-leaf node of this tree, it represents a threshold gate, and it is actually described by its children and the threshold value. So this threshold value is the THX. It should be greater than 0, but it should be less than or equal to its number of children. Okay, so when this threshold is having the value 1, then this gate is the OR gate. And when this threshold is having the value of its number of children, then this threshold is the AND gate. Now, for the leaf node of this node X, so the leaf nodes, they are actually described by the attributes, and they have the threshold value TH of X. So let us see how this access tree, when it is, how it is being satisfied. So until and unless this access tree is satisfied, the access structure is not satisfied, and hence the policy will not be satisfied. So ultimately, we have to use this mechanism of satisfying an access tree. So a user will be able to decrypt the ciphertext when the given secret key, means with this given secret key, it satisfies the attributes that is assigned in the ciphertext of that access tree. So let us say that this access tree T has a root R, and the subtree of this tree is TX. So again, means we have to make the calculations by using the means recurrence mechanism, because for every node we have to go for its children until we reach the leaf node. Okay, so we have to compute a value Tx of means the value of the threshold for one children is 1. Means it returns one value for at least one of its children. Then this value will be 1, Tx of gamma. So by using a recursive function, this is being calculated. From the root node we start, but we go onto the leaf node, and this value is being returned. Whenever the attributes has been satisfied, then it returns the value of 1, and at least one present value of children should return. So if it is an OR gate, then one children will return the value of 1. If it is an AND gate, then both the children must return the 1 value. So likewise, we will reach again to the root node, and it will we will get the value of 1. So we will say this access tree has satisfied. Okay. Now, this is an example for our case here. So this access tree here at the root node, we are using the AND gate, which is 2 of 2. Again, it has 2 children. So one of its children is having another AND gate, 2 of 2, and another one is having 1 of 2 gates. Now, this node is having 2 children, which are the leaf nodes of this tree. So the leaf nodes represent the attributes themselves. So the first child is having the attributes XYZ hospital and cardiologist. And the second child is having the attributes Dr. X and Dr. Y. Okay, so now if a message is encrypted for this example, then the user with the attribute set XYZ hospital and cardiologist and Dr. X. This first criteria, this has to be satisfied, this attribute, or XYZ hospital and cardiologist and Dr. Y. So this 2 of 2 means both the attributes need to be satisfied, and 1 of 2 means only one of the attributes need to be satisfied. Then this will give you the value of 1 for its threshold. Okay, so this user who is satisfying these 2 attributes will be able to decrypt the ciphertext using the keys. Otherwise, he or she won't be able to do that. So this is the example. Now, coming to the categorization of ABE schemes, we have 2 types of ABE schemes. First one is the key policy attribute-based encryption, that is called KPABE, and the second one is ciphertext policy attribute-based encryption, that is CPAB. So what happens in key policy KPAB is that the policy that is associated with the key, and the ciphertext is created by using the set of attributes. So in KPAB, the ciphertext is embedded with the receiver's attribute set, and the private key or the secret key or the decryption key is associated with the access policy. So in KPAB, user secret keys are generated based on the access tree, in our case, that defines the privilege of the concerned users, and the data is encrypted over the set of attributes. Whereas in case of CPAB, the policy is associated with the ciphertext, and the decryption is decryption key is associated with the set of attributes, just the reverse of the KPAB. So here the private key is embedded with the receiver's attribute set, and the ciphertext is associated with the access policy. So here the CPAB, here the access trees, it uses to encrypt the data, and user secret keys are generated over the attribute set. So how this works, let us see for our system only. So here we have a single public encryption key PK, let us say PK, and we have a group of decryptors. So we have to generate a group of decryption keys here. Fine. So initially, the center, that is the key generation center or the key management server also, it generates the public key and its own master secret key, MK. So first, this key generation center, it verifies the validity of the user attributes, whatever users attribute, the credentials it is providing to the center. So it has to verify, the center has to verify those credentials of the users. So after doing that, it takes its own public key and the master secret key and generates the decryption keys of the users at random. Okay. Now, this generation of the decryption keys of the users can be done when the application is initially at the initial stage of the application, or it can be done as the application is being used in real time. scenario also. So it depends on the application. Whenever these keys are needs to be generated, and in the beginning also it can be generated, or in later stages can be generated, and then it distributes them to the group of decryptors over the protected channel here, because keys are being sent here. Okay, so now it depends on what particular type of AB we are using. If we are using KPAB, then here the access policies are built in the secret keys or the decryption keys, and the attribute sets are in the ciphertext. So what happens here? Let us see an example. Is this slide visible to all? Example slide.
Yes, ma'am.
Okay, so
Yes,
here, here what happens? The policy is associated with the keys, and the ciphertext is having the attributes. So C1 is the ciphertext, and it is having the attributes. Say it is having the attributes 3, 5, 6, 7. These are the attributes associated with the ciphertext. Now, a group of decryptors is having the keys with them, and the keys have the policy in it. So let us say that, say here K1, for the first key is having the policy 1 and 2. The second key is having the policy 3 or 5. The third key is having the policy 1 and 2 or 3 and 7. Fourth one is having the policy 3 out of 1, 2, 3, 4, 5, 6, 7. See here, this case K4. K4's policy is other than AND gate or OR gate. Okay. As I said earlier, that any combination is possible other than the AND and OR gates. So this is such example. It is neither an AND gate nor an OR gate. Okay. Again, K5, 2 out of 1 to 5. So these are the policies, 5 policies associated with the 5 decryption keys. So the ciphertext is having this attribute. Now let us see which key will be able to decrypt the ciphertext. Key 1, 1 and 2. So neither 1 is present as the attribute in the ciphertext, nor 2 is present. So by using key 1, K1, we won't be able to decrypt the ciphertext. Now K2 is having 3 or 5. So 3 is also present, 5 is also present. Only 1 is sufficient. Okay, so K2 will be able to decrypt the ciphertext. K3, 1 and 2 or 3 and 7. So the second part satisfies. So K3 will also be able to decrypt the ciphertext. K4, 3 out of 1, 2, 3, 4, 5, 6, 7. So 3 is present, 5 is 7, 6 is present, also 7 is present. So K4 will also be able to decrypt this. And K5, 2 out of 1 to 5. So only 5 is present in the ciphertext, and 1 and 2 are not present. So K5 is also not be able to decrypt the ciphertext. So this is how KPAB will work. Okay, now and let us example of this. So policy is 1 and 2 or 4, 7. So this is the associated ciphertext and keys are having the attributes. So these are the 5 keys, 1, 3, 4, K5 having that. Again for K1, what happened? No. Again for K1, which is having attribute 1. So 1 here, it requires 1 and 2. And or here 1 is not present. So K1 will not be able to decrypt the ciphertext. Similarly, you can self-access that how K2, K3, and K4 will be able to decrypt the ciphertext, because K2 is having 1 and 2. And here 1 and 2, it is satisfying. K3 is having 4, 5, 6. So the policy says that 3 out of 4, 5, 6, 7. So again, 3 will be able to decrypt. Satisfying. So K2 will be able to decrypt the ciphertext. Even K1. So in both the cases, the encryption time and the ciphertext size they are linear to the number of attributes in both KPAB and CPAB. Now the security analysis. So now the schemes are when incorporated with our application in health sector. So it needs to be analyzed whether it is performing the standards, whether some attacker will be able to break it or not. So for that part, we require whatever scheme we provide, we need to provide the security analysis of that scheme. So this is also done for the case of AB. So what is happening here, we have 6 phases for security analysis, and it is a game between the adversary and the challenger. Okay, now the adversary has to guess the right message, encrypted message, then the adversary will win. So the 6 stages involves a game between these two parties. So what happens initially, the adversary declares the set of attributes that are to be challenged upon. Okay. Slides are visible, right? Mm,
Yes, ma'am.
okay. Okay. So the attributes are declared by the adversary that are to be challenged upon, and then the challenger provides the public parameters to the adversary, whereas it keeps the master secret key with master key with itself. Now the adversary is allowed to issue the queries for this private key. Okay, and means this will be done because private keys, it is associated with the access structure. So for many of the access structures, the queries are being done by the adversary. Okay, so this access structure, it does not include all the attributes that are initially declared by the adversaries. Other than those attributes, the access structure is means the queries for the access structures are being done by the adversary. Now, in the challenge phase, which is the important phase, is that the adversary submits equal length 2 messages of equal length, M0 and M1, and the challenger, he will flip a coin, and based on what the coin means output of the coin, whether it is head or tail, he will encrypt the message on that. Means that particular, it will encrypt the message M0 or M1 based on that. Okay, so if the outcome of the coin is B, then it will encrypt MB with this attribute gamma, small gamma. Then the ciphertext is passed to the adversary. Now the adversary phase 1 is repeated. That is, the adversary now issues some of the queries for the private keys based on the access structure that does not include gamma, all the attributes that are in gamma. Okay, that's it. So this phase is repeated. Many times this is repeated. And finally, the adversary will output the guess. He will actually guess which message was encrypted. Okay, M0 or M1. And the adversary wins if it can successfully guess B prime of B, if it successfully guessed the message. Okay, but and throughout the game, the adversary has an advantage that is given with this probability. Probability of B prime is equal to B minus half. So this is actually a mathematical proof that we used to do when we provide a scheme, and we have to show that in spite of this advantage that the adversary is having, the adversary won't be able to guess the correct message. Okay, so this is how the security analysis has been done for AB. Now the formal structure of KPAB. So it has 4 algorithms, 4 phases. The initial phase is a setup phase, which takes the system parameters and it generates the public parameters and the system master key. So this algorithm is executed by the key generation center or the key authority. The second phase is the encryption phase, where the original message of the sender is taken and the public parameters or the parents that the key authority has provided in the setup phase, that is also considered, and the attribute set omega. These 3 entities are considered, and the ciphertext is being output. And this is done by the data sender. Then the next phase is the key generation phase. It takes the access structure, the system master key, and the public parameters as input and outputs the secret key, the decryption key. So this algorithm is also executed by the key authority. And finally, the 4th phase is the decryption phase, which takes the ciphertext, the secret key and the public parameters, and it outputs the original message. So this algorithm is executed by the receiver. Similarly, the formal structure of CPAB also comprises of 4 phases. The setup phase, it takes the system parameters and generates the public parameters and system master key. The second phase is the encryption phase, where the original message, the public parameters, and the access structure is taken as input, and the cipher text is the output. Key generation phase takes the system master key and the set of attributes as input, and generates the system secret key as the output. And in the decryption phase, the cipher text, the secret key, and the public parameters are taken as input, and original message is produced as the output. Now I'll explain one example of IoT enabled scheme that is based on AB for the healthcare sector. Okay, so what happens when we use AB? So here the sender encrypts a single message for a group of receivers. So as our situation requires that, we use this. So you may also think that there are several other schemes that are that the applications of health sector uses for IoT. But what happens in most of the cases, since IoT is very much resource constraint, we have we require very less computation for all the applications. So a special techniques which actually uses less operations for computation, they are required. So this particular scheme is actually using that type of mechanism that is called elliptic curve cryptography, or ACC. So that technique is used for AB here, that is also included in this particular scheme, so that IoT application gets lightweight and the overhead gets reduced, and the system becomes more efficient over here. So this is a scenario. In the left-hand side, you can see that we have the patient, and the patient is having many sensors with him that collects the data from his body, and it sends all the sender to data forwarder. So this data forwarder could be any system. It could be your mobile phone also, smartphone also, or your computer system also. So this data is being collected in this system, and these two things comprise the wireless body area network, WBAN. Okay, so at first, and we have another entity that is the key generation center and a medical server. These two comprises the middleware of our application. So, and the third entity becomes the data receivers. That could be the hospitals, the doctors, nurse, or any other people or entity that is providing the health service. So in this case, what happens at first, the public parameters are being generated by this key generation center, and by using the policies, access policy, this data that is being received by this data forwarder, it encrypts the data and it uploads in the medical server. So all the encrypted medical data is kept in this server. Now, whenever the receivers, data receivers, it could be the doctor, nurse, or any other medical attendant. So whenever they require the medical data, they at first request the key generation center for their decryption keys. So after that, the key generation center, after verifying the user, it will provide after authentication also, it will provide the keys to the user, medical attendant. And by using that key, it will first download from the medical server the data, and it will decrypt and take the appropriate decision and provide the service. So this is how this application works. So for this, how we can do this? We have to consider these 3 entities. The first one is the key or the attribute authority. Another is the data sender, and third one is the data receiver. So these are the 3 entities. So at first, what happens? The data receivers, it takes the set attribute sets and registers themselves with the key authority, and it provides the unique identity, user's identity, UID. So this key authority also maintains a list of such UIDs for every receiver corresponding to each receiver, and it also defines the universal attribute set U. and the access structure gamma for data receivers. So this comprises the initialization phase. Then for the setup phase, as we have discussed earlier also for the KPAB, so what happens, each attribute, say AI, that belongs to the universal attribute set, the key authority chooses a parameter, a value Si that belongs to the set ZQ star. So this set is the set of integers. Okay, now this integers is prime here, taken considered as prime. So set of prime integers that have the multiplicative inverses in also means in that set. So that is why it is ZQ star. So from that set, randomly one integer is chosen uh, by the key authority, that is called SI. So the public key for every attribute. So for every attribute, this is being done. So for every attribute, now the public key becomes this randomly chosen integer SI from this set multiplied by the group generator. This is the group generator, capital G. Okay, so this becomes the public key for every attribute here. Now here the application's lifetime is considered because here means the keys are being generated, or they are being updated at regular time intervals, rather than providing only one key which is being used to decrypt for the entire lifetime of the application. This application is divided into discrete time intervals. Okay, so for every time interval, a fresh key is being generated here. It has many advantages that are means the advanced topics. Okay, so the time intervals here are denoted by TI0, TI1 through TIM-1. Now the authority also chooses another means value TJ that also belongs to this set ZQ star for every time interval, each time interval. Okay, for the application's lifetime. Now another function, capital H, is here chosen to map the user ID. Means it will include 0 or 1, which maps the user IDs to the unique element of the finite fields of the integers ZQ star. It also chooses the master secret key authority, small s, uniformly at random from the same set. And the master public key is calculated by multiplying the smallest with the group generator. And the system master key is also calculated, which comprises the value of the small key, the TJ that was earlier chosen from the set, and the SJ that is also earlier chosen. So these three parameters becomes the system master key here. And the public parameters are given by this master public key, MPK, the PI, that was the public key for each attribute, initial first calculation, and this function H. These three comprises the public parameters, params. Now for encryption, what happens? The session keys are here actually encrypted under the attribute set omega. So for that, the sender randomly chooses R from the same set ZQ star and computes K prime. That is a multiplication of R with the MPK. So since we have considered elliptic curves here, so curves are having a coordinate. So any point on that curve it has two means axis. One is the abscissa, x-axis, another is the ordinate, y-axis. So any point. So if, when we are choosing this and we are multiplying it with a point, so it becomes a point, and it at every point has two coordinates, kx and ky. That is why we are getting here two values, kx and ky. So this is another advantage of using the elliptic curve techniques here, because we can use these two values for two purposes. One should be used as a key for encryption, and another value is used for checking the integrity of the message. That is also required. Okay, so here kx is used for encryption as the encryption key, and ky is used for the kept for the for checking the integrity of the message. So for every attribute in the authorized set omega, the value of ki is calculated such that ki becomes r dot pi. Okay, for all I belongs to omega. Now the CP and the message authentication. This is kept for checking the integrity of the message. They are calculated as M encrypted, and the message authentication code, it is using the hash function sha1, and it is hashing what it is taking two values, that is the message and the other key, integrity key, that both things are being hashed together by using sha1 function. So that is the message authentication code, MAC-M. So the ciphertext now comprises of the attribute set omega, the CP encrypted message, MAC-M message authentication code, and KI. So these entire things become the ciphertext, and it is sent to the server. So here, since we are generating the decryption keys depending on the time interval, so at first the initial secret key needs to be generated. Okay, so when the key authority receives any request from the receiver, so with his or her UID, it initially it generates the initial decryption key component at the time interval TI0 for the attributes that are specified in the attribute access structure. Okay, so here the concept of polynomials are used again. QU is a polynomial with the degree THU minus 1, and it is assigned to each node of the tree, because for access structure we need the access trees. Okay, so here we have to visit the nodes for whether the access tree has been satisfied or not, to check for that. So here the polynomial is used whose degree is THU minus 1. Now for root node, it sets the value QR. This is also the polynomial for that node, QR of 0 as S. S is already defined in the setup phase, initialization phase rather. So for all other nodes, the authority sets the value QU0 as the Q parent of U and index of U, which node it is visiting. That is the index. Okay, so initial key generation here for the leaf nodes polynomial, the secret share of the secret key is embedded with that leaf node. Means the attributes are present in the leaf node as we have seen in the example XYZ hospital. Okay, so that is being stated for the leaf nodes polynomial. Now the initial secret key for each attributes where it is actually the set of leaf nodes at time interval T0 is given. It is given by this value D of DTI0. That is DI dot T0. Okay, where DI is the this expression. This is taken from the Lagrange interpolation. Okay, this capital DI, this expression QU of 0 by SI of H is the function that was already given for the EUID. So this is taken from the Lagrange interpolation expression. Now, these things are calculated by using this. The initial secret key is generated. And for every time interval, this value of D of TI is updated by using DI. It is calculated already, and the value of TJ. It is taken for every time interval. So every time interval has its own decryption key. It is refreshed rather, the keys are. So for the decryption purpose, the receiver, they submits their these parameters to the key authority for obtaining their secret key. When they get their secret key, they can use. There are several steps over here. The K authority first verifies the user, and if it is verified, it retrieves the corresponding user ID. Then it computes the secret key at the jth time interval, whether which time interval it is actually executing, it will check for that. And for that time interval, it will compute the secret key. Here it is denoted as XI, that is actually the DI in the last slide. And it securely transmits that secret key to the receiver. Okay, now the decryption is done recursively by the receiver for every node. So starting from the root node, recursively for every node, the decryption mechanism is done, and it is here given by this function, decrypt ABE. XI is the secret key, DTIJ is the initial secret key, and U is which node. Okay, sometimes it will be the root node, sometimes it will be the children node, and sometimes it will be the leaf node. Okay, so this is the calculation that is being done here. In every case, whether it is root node or non-leaf node or leaf node, it will yield to, finally it will yield to, it is a long derivation, so I have not given the derivation here, not kept it in the slides. So ultimately, in the last few equations, it will give this value, QU of 0. It will yield this polynomial rather. So for this polynomial, the value is being set to S and R dot G is given. So from this, we can see that S dot G was MPK, so R dot MPK. So we get KX and KY here. Rather, it is denoted as KX prime and KY prime because we do not know what is the value, actual value of KX and KY. Okay, so KX prime and KY prime. So here KX prime becomes the actual decryption key and KY prime becomes the integrity key. So by using KX prime, the message that is being received by the receiver, data receiver, it is decrypted. So the CP will be retrieved from that. CP has 3 or 5 parameters, and KX prime will also be retrieved from that. So it will be checked whether the message now, for integrity check, whether the message has been altered or not. The same function will be applied on the message M prime here, because the message has been received, it is whether altered or not, that needs to be checked. So we are denoting it as M prime. So the same SHA1 function is applied for that M prime and KY prime. If the hashed value is same, then the message is intact. If the hash value changes, then we can assume that the message has been altered here. So like in this manner, both the decryption is also possible here, and the integrity check is also done by using the points, the two keys that we are getting from a point. So this particular scheme provides confidentiality, integrity, and authenticity, everything, which are the basic requirements of any security applications. Any applications need to be secured. Okay, so with this, I'm almost, I have concluded. So for conclusion, I will say that if we use IoT technology for healthcare industry, then we get a lot of benefits, but none of the advantages are free. So we need to be concerned about the security factors because this application, IoT application, has a lot of data that is traversing freely if you do not provide security mechanisms to them. So we have to keep any security, strong security mechanism to protect the data. And since AB satisfies all the components for the healthcare sector's requirements, so we use AB scheme here, and it has given good results when we have compared with other schemes, because other schemes are also there. AB with bilinear pairing is also there, but it has a lot of computation. It takes too much computation, so overhead is too high. So when we have also checked for the other schemes, but we have found that if we use the lightweight scheme such as ACC, then the results are much improved. Okay, so AB as a security solution for IoT-based healthcare system is one such efficient and effective solution. So now I would like you to ask me if you have any doubt regarding this session. Stop. So anyone has any query?
Any question from audience? Okay, I think there is no question. I have a small question regarding cluster-based decryption.
Yes.
What about the attribute-based encryption, and then the encrypted message or ciphertext will be broadcasted to the cluster.
Yes.
If there is any matching with the policy, then
Yes.
only data will be decrypted, right, ma'am?
Yes. Yes.
Okay.
Hmm.
And in that case, what about the encryption key or decryption key? That will be generated with the help of attributes.
Yes. Actually, depends if we use the KP mechanism, means key policy based attribute based encryption. So
Yes.
in that case, the key is associated with the policy.
Right.
Okay, and if we use the other one, then in that case, the ciphertext is associated with the policy. So it depends. So whether the attributes are actually being used in the keys and or the policy is used for the keys.
Okay. In that case, my doubt is
Yes.
the encryption key is similar to decryption key.
No. It is used. It is for the decryption key actually.
What about the session key is generated using the attributes of the parties, and that key will be shared with the other party or recipient? Is this like this?
For the encryption key, no, it is actually it is also based on the attributes when the receivers are actually getting registered with the key authority. So depending on the attributes, the encryption keys are generated.
Okay.
Depending on the attributes, the encryption keys are generated.
Right.
Hmm.
And decryption key, ma'am? What about decryption key?
Decryption key is another thing that is depends on the means policy or the means again with the attributes also that are different. The different decryption keys are different and encryption keys are different here.
Okay. Okay, thank you, ma'am.
Hello, ma'am.
Hello. Yes.
Ma'am, any other cryptography primitive like ECC? You told me ki lightweight compared to the bilinear pairing. Any other lightweight cryptography primitive except the ECC?
Identity-based cryptography is also lightweight, but in this case, we do not have that means one-to-many correspondence for identity-based. So IB is also lightweight. In other applications, IB can be used. Means if we do not have a group of decryptors, then IB can be used.
Oh, ma'am, told me ECC is a lightweight compared to the bilinear pairing.
Yes.
Yeah,
Bilinear pairing is different thing. Means for public key encryption you are saying, or any mathematical technique you are using. Means ECC is used with the public key encryption mechanism. ECC is completely a mathematical technique. Now how you are using ECC in which security scheme? Like ECC can also be used for creating digital signature mechanisms also. Okay, so ECC can also be used for this encryption mechanism also. Okay, ECC can also be used for any other authentication techniques also. The authentication technique, digital signature technique, or encryption technique, security techniques. And ECC is a mathematical technique that is used here, or means that is included in the security techniques. So bilinear pairing is a mathematical technique. Okay.
Okay.
Hyperelliptic curve is also there, but it has other drawbacks. Some of the drawbacks are there. Hyperelliptic curve is also lightweight as a mathematical technique. And
Compared
for
to the ECC.
no, not compared, not in comparison. But some of the researches are going on with hyperelliptic curve. So, but it is lightweight with respect to bilinear pairing.
Okay. Okay. Thank you.
Any further question from participant? Okay, I think there is no further question. So thank you very much, ma'am. And thank you very much for your time, for accepting our invitation and manage your busy schedule to deliver your session. And obviously, I would like to invite not only you, but all the speakers to visit our college in offline mode. And whenever I will or we will conduct any seminar in offline mode, then I will request you to visit our college to deliver a session. I think it is a small college with respect to NITs or IITs. Still, you will love it because the campus is very beautiful, and as it is a college in remote area, and you know, as you have already visited different places of Duars or Darjeeling, Sikkim. Still, I think there is a inbuilt beauty of this location. So that's why I expect that you must try to visit our campus at least once. And
My
thank-
pleasure, sir. My pleasure. I would love to visit. And no institution is small or big. Okay, it is an educational institute. That is the what matters.
Right. Thank you, Besh.
Hello, ma'am.
Yes,
Can you share with PPT with us?
I will send
Yes,
to.
yes.
Sir. I'll send to sir. Sir will provide.
We will share in the group, as I have already shared the previous PPTs. Okay. Okay, ma'am. Thank you very much.
Okay, thank you, sir. Thank you.
Hello, Kaushik sir. Are you in the meet?
Yes, I have joined.
Okay. Okay, then we can start our second session. The second. Now, after a beautiful session on healthcare data security, now the next session of third day is delivered by Mr. Kaushik Halda, Head Education Information Security and Emerging Technology OEBL, and his topic is AI in Cyber Security, Strengthening Cyber Resilience. And about Mr. Kaushik Halda. He is the Head Education Training, Information Security and Emerging Technology OEBL. Kaushik Halda was a student of computer science and an alma mater of the University of Calcutta, West Bengal, University of Technology, Institution of Engineers, India, Indira Gandhi National Open University, National Institute of Technical Teachers Training and Research, Kolkata, Indian Law Institute, Delhi, and National Law Institute University, Bhopal. Sri Haldar was conferred with the gold medal from the Vice Chancellor of West Bengal University of Technology for securing first position in post-graduation examination. Mr. Haldar holds certificate in project management, cybersecurity, cyber law, data privacy, GRC, cybercrime investigation, and digital forensic. He completed National Cybersecurity Scholarship Program by ISAC MDI Gurgaon, and he is member of prestigious National Security Database of ISAC. After completing his education, Mr. Halda joined academics and served universities, colleges, councils for long period. Along with his teaching career, he also spearheaded digital transformation of different e-governance ecosystem over the last 25 years. During his current tenure in the OABL, he served the corporation having been posted at various verticals and was playing a major role in recognition of OABL by CERT in Government of India. Under his leadership, OABL set up Center of Excellences on 3D printing, cybersecurity, artificial intelligence, and machine learning, IoT, sensors, and also entered into many successful collaborations like with University of Calcutta, Jadavpur University, CGCRI, EC Council, Data Security Council of India, and many more. He was conferred Certificate of Appreciation from the head of the corporation for his professional excellence in the year 2024. Now I would like to request Mr. Murshid Haldar to start his session. And his topic is AI in cybersecurity, strengthening cyber resilience. Over to you, sir.
Good afternoon, Professor Burman. Good evening, Professor Burman, and good evening to all the participants for inviting me in this session. So, to start with, I would like to take apology from all of the participants, those who have joined. Said, as you have to understand that since I'm a government officer, my today due to certain meeting, I have to join this meeting late. So I am now on the move. So you may face some kind of trouble in network for next 10-15 minutes, and thereafter it will got stabilized. I will reach to a station. But let me tell you one thing before start of my lecture. My topics in AI in cybersecurity resilience, to make a state cybersecurity resilience. When we started our journey in cybersecurity 8 years back in the state of West Bengal, we do not have any idea regarding how to make a state or how to make a organization or how to make a university or how to make a college a cyber resilient. So what we created a center of excellence called Cybersecurity Center of Excellence, which is basically which has 4 vertical and 1 horizontal. Why I am telling this a brief background. Please allow me for next 5 minutes to tell the background of the cybersecurity ecosystem in our state as well as in the country itself. Many of you must be aware of that, but although I am for the information of everybody, I am telling that we have created a cybersecurity center of excellence with 4 vertical and 1 horizontal. What is the 4 vertical? 1 vertical is awareness generation and capacity building, which primarily belongs to you, because your job is to build capacity amongst the youths, maybe through engineering education, maybe through college education, or maybe through higher education, in whatever form. So build capacity out of it. Our target or motto is to build capacity out of it. Then to build cyber assurance in the state. That is why to make a cyber resilient state, then I will come to my topic later. To make a state cyber resilient, you have to make your state application and infrastructure secure. So for securing the state application and state infrastructure, we have created a kind of cyber assurance plan for the state, which is basically helps us to create a kind of what you say, kind of certain laboratory first in the eastern India in West Bengal. Thereafter, we created another vertical called cyber forensic, which is a very important trade which is presently coming out. Then we created another vertical called security operations center and network operations center. And then we created a horizontal, which is of your interest, called research and development in cyber security. So from this research and development in cyber security, we lead into a point that yes, for doing research in the cyber security, we need to use of artificial intelligence in the cyber security to understand the threat and understand the threat landscape and understand the risk appetite of an organization. You have to understand the use of AI in cyber security is just to understand the skill risk ecosystem of the state, or rather not state, of a application of a infrastructure, to find out the entire part of it. And to do that, what we did initially, we did exposure management. I will come to the presentation just 5 minutes after. If you allow me just 5 minutes, I will give you a presentation on exposure management, and you will be able to identify from where the cyber security use of AI can be used to make a cyber resilient. But as I have understood from Professor Borman, that you are all professors, research scholars mostly are here. So I will request you that your job is to train people on cyber security and doing research using AI in the cyber security. I try to give you a direction that where are the areas currently we are facing challenges in the area of cyber security, and uh, it will continue to do so. So this is the my first introduction regarding the cyber security landscape in the state, and I hope you will understand that what my motive is, why I am trying to put this background to you, as I have to create this ecosystem in the state with because if I talk about the industry, if I talk about the startups, if I talk about the anything which is related to the area of cyber security, nothing can work without the academics and research, because student is the need of everywhere and anywhere. So that is why I am setting this context to you, that use of AI in cyber security in my present lecture context will invite you to give you a clear direction that this is the area where we want to teach into, and this is the problem statement which will we like to give. Am I clear, and does it make sense?
Yes, sir.
Okay. So now, if we go to the contextual, just allow me 2 minutes. Just allow me 2 minutes to open my laptop and getting it connected. Just allow me 2 minutes, please.
Is my screen visible?
Yes, sir.
Yes. Thank you. So, is it visible? So, this is the with respect to securing of use of AI in making a setup cyber resilient. We are targeting or focusing on a securing exposure over the endpoints. How many of you idea about this exposure management? Anybody has any idea about this exposure management? Anybody in the room has any idea about the exposure management? Can anybody, hello, am I audible?
Yes, sir. Audible.
Has anybody any idea about exposure management? I'm just asking the participants.
No, sir.
No, you have no
No.
idea. So what is anybody's idea about the security in over the endpoints? How you define the security? Can anybody answer? How you define? Let us make it interactive. Do not take a placid lecture only. So in security system, what we did normally, a normal practice is we are to secure a system. We first we created an infrastructure at the endpoint level. Then we connect this infrastructure to a server over the internet and access and place some application on the internet or over the server itself and access the application over the endpoints. Correct. So our idea is to starting from endpoints where you are monitoring, we secure endpoints by giving antiviruses. We secure server side by giving firewalls, routers, and everything. We are securing everyone by giving different softwares from ours. But that security to make it cyber resilient, the days are gone, because you have to use artificial intelligence over the endpoints, because over the endpoints there are no one sitting with you who is managing or who is overhauling the network or monitoring the network and securing, giving you the feedback over the exposure that yes, you have that kind of exposure over the endpoints. So that is where the role of AI could come into, because you probably you understand the you all are computer science graduate or computer science researchers are there, some security people is also there. The every data packet flowing over the network, generating huge amount of data to the network, and which is collecting, getting over the routers, the switches, the servers, and everywhere the network logs are being created. Correct. So you have to analyze those data and find out the trends of your packets and create a exposure shell over your endpoint, so that the packet when coming to the network, packet when coming to you, you more become reliable and flexible, that the packet is securing exposure over the endpoints. Next. So if you go to the latest certain guideline, you will see that there are common vulnerability exposure, which is mentioned in the OWASP guideline, which is mentioned in the MITRE ATAK framework, which is mentioned in the SANS 25 network. What is CVE? CVE is a vulnerability that overtly stressed up. Exposure is that which is silently kills. Vulnerability, we are always talking about the vulnerability. This is vulnerable, this site is vulnerable, this packet is vulnerable. But exposure, your exposure to a scenario. So this is more vulnerable than the vulnerability. All vulnerabilities are not exposure. All exposure are not vulnerabilities. How you distinguish between the vulnerabilities and exposure? I'm giving you a common example of vulnerabilities. Let us understand SQL injection. SQL injection is a vulnerability. You must have to understand that SQL injection is a very common vulnerability exposure which normally resides with the application. We are very sure on that. But you have to think that why and how common vulnerability exposure that SQL injection occurs. Tell me, any one of you, if you can tell me that how and why the vulnerability exposure occurs, it will be rather better, good for me to carry out with this conversation, because I also have to understand, because how and why the what do you say that SQL injection occurs? That is, we collected the vulnerability exposure data of many government websites. We analyzed through a large language model. We have created a model out of it. 2 PhD students works on that, and they find out a solution that the entire perception, the common vulnerability exposure comes from the insecure design of our application. Right? And based on that, we came out with a course called Secure Coding Practice Framework, which is recognized by certain thereafter, which should be taken up by every faculties or every one whosoever attached with this cybersecurity kind of courses, because you have to understand that insecure design of a vulnerability will kill your application. So that is why I have told you that all vulnerabilities are not exposure, but all exposure. That exposure means here the insecure design is the exposure. Correct? So these vulnerability leads out of insecure exposure. There might be some vulnerabilities might coming from the network, might coming from the side channel attack, might coming from the cryptographic encryptions, might coming from the other different specs. They are not always treated as exposure. Endpoint security is now that is the end of era. Till the new millennia, endpoints ruled. Y2K bug and overambitious apprehension boosted the need. Rise of social media, ushering in redundancy in connectivity. So where is the structure? The structure is SWAN, MPLS, and then SWN. So this is the structure where it is going, because there is no such information available right now with the endpoint security, but as we have designed a security operations center in our state government department itself, where every day systems are collecting log from various sites. That is not from the what do you call? You must be agree with me. The amount of internet that we are seeing, that is only 5% of the overall internet. 95% is in the darknet. The data that are rolling out of the darknet, the databases that are rolling out in the darknet, if you cannot use any model out of it to find out the pattern of yourself, the endpoint security will not be able to judge on that, because endpoint security only works on the published virus which are published officially over the internet. So these are not the limit, because you have to understand. I am acting as a cybercrime officer in the state, so I have seen that the most of the cybercrime happens from the darknet. The lots of datas are taking from the internet. They are processing over the darknet more intelligently than us. They are rather using AI to generate the next data set, taking out the pattern out of it and launching that. So at the same time, we have to use the artificial intelligence. Most of the OEMs, most of the cybersecurity product making organization started including artificial intelligence over them. We are in discussion with them. We are securing the exposure over the endpoint, so that it is not right now your computer or your internet or your network bandwidth is not only the threat perception. You have to use AI beyond it so that it can make the entire system cyber secure beyond the endpoint security. If you consider peripheral security, it is a firewall, it is a sandbox or honeypot, we say. We have seen SOAR, we have EDR, MDR, and XDR. Anybody who is the if he are associated with data center, they might have aware of these EDR, MDR, and XDR. Now we are creating a new system. We are coming out with a new system that exposure over the internet. We are in discussion with some OEMs. They are making some kind of product we will use in our own state data center and try to make secure that connections which are normally coming, which is not actually showing as vulnerable. They might be vulnerable because we are allowing them to pass through without any inspection. So these are some kind of peripheral security you might have seen. You have raised that in the entire network architecture, these are the steps that these are the hardwares we normally install over our network as a peripheral security, because when a connection coming to periphery, then it enters into the system and then it hit the bullseye. Correct. So if you see the peripheral security downside is it's now there is a lack of IPsec tunnel. There is a prohibitory cost because all the softwares are very costly. There is a lack of qualified manpower. Why I have given this lecture to you, because you have to understand that your normal, I don't know how much you are taking this FDP as your really career development growth. If you consider your really career development growth, you have to train your students on how to work on the peripheral security, how to work on the network security, how to create or manage a ethical security part of it. And for that, you have to get yourself trained, because really we need lots of qualified manpower in our ecosystem who are knowledgeable on the security part of it. The exponential rise, because you have seen that if 5G, nowadays 4G is rolling. In Singapore, they have already rolled out 6G, 7G. We have rolled out 4G successfully. BSNL going to roll out 4G maybe by end of this year, or already they have rolled. Then we will go to 5G. Some private players started playing with 5G. You understand, the 5G will operate on the street furniture. We have in our state government, we have identified nearly more than 45,000 street furniture where the 5G application box will be placed. You have to understand the IoT will get raised. The number of connected devices will increase. The number of threat perception, the lot of data will get generated. So we have to use AI. We have created a center of excellence on data science and machine learning in our state government in the Department of IT and Electronics. I would request all professors or research scholars, those who are present there, please come and connect with our COE. We are allowing projects to build it here. We have created a 160 petaflops GPU computing data center very near to Jalpaiguri Government Engineering College, that is in Siliguri itself, that will going to inaugurate it by probably by the next month. So we are, because you have to understand that if you have to work with AI for the cybersecurity resilience, as a professor, you need resources, you need computing resources, and you need data. So these two things are challenging with respect to, as I have seen in AI, working with AI and cybersecurity both. These two things are challenging with respect to AI and AI research and further development. So from the state government itself, we are allowing 160 petaflops data center for the academic institutions. First time in the country itself, we are allowing for the startups also. that with a very nominal price model. That is also very because the price model only to cater the make the ecosystem stable and make the ecosystem up and running. So it is not that government will do business out of it. But we have came out with a 160 petaflop GPU data center. Whatever the data source that we are created with respect to our state data center, our state development wide area network, our MPLS connectivity, in all cases, the data asides right with us. If anybody comes with a project, we will do a NDA with them. We will share data to only to the academic institution for research purpose. You come up with a solution which we will place to a startup, because it's a complete ecosystem we have to understand. As Professor Borman was telling that I am already initiated many center of excellences and managing many center of excellences initiative taken by the government. I've seen that there are very disconnect between the professors, those who working in R&D projects. After publishing a paper, their work finished. They do not commercialize their research. So my submission to all of you that this lack of qualified manpower starts from your ball game, that how you train yourself up, how you make yourself gear up with the modern days application. This is not that all about writing a paper. You have to understand, in our government we do not write papers. We have to give certain kind of delivery to the citizens as per the citizen services concern. So why we are concerning about the peripheral security? Because there are some problem statement identified. If somebody from your group or the professors or the lecturers, maybe through appropriate channel, Jalpaiguri Government Engineering College is the North Bengal Extension Center of our Cybersecurity Center of Excellence. If you see that, if you apply through them, that we can want to join AI, use of AI in cybersecurity research work within this problem statement, we can happy to take this up, because if you want trained, then you will inculcate this into your manpower, in your students, then student will got trained. Because what do you require? You require the computing, you require the cloud. We will provide you the computing cloud itself at a very throwaway price from or rather from the government itself. Sometimes it comes as a free also, but policy has not yet decided. So my point is that the exponential rise in the connected device will lead you to the exponential rise in the what do you call exponential rise in the attacks also, exponential rise in the data also. So it's the right time, so that if you see that the IoTs, IIoTs, all will be connected over the 5G and 6G. If you have to take this forward, you have to understand that the research should come out, the our institute should come out with proper curriculum, institute should come out with a proper course to create and generate this kind of manpower, so that in security you have seen that this kind of project should take place. So here I take a just 2 minutes pause and wait for questions if you have any up till this, then I will move forward. Has anybody any question on this? Or shall I move ahead? Should I move ahead? Okay. So, just a minute. So if you see that, what is exposure management? It is look beyond the endpoint, assess risk landscape. It is network analysis on the go. It is exposure of access, not the endpoints. It is piggyback protector. So look beyond the endpoints means you have to understand that as I was telling that endpoint is not the last mile connectivity. You have to go beyond the endpoint. You have to assess the risk landscape. How do you assess? How could you assess the risk landscape? You have to understand. How could you assess the risk landscape? Assessing the risk landscape is you have to understand your risk appetite. What is the risk appetite? Risk appetite means how much risk I consume. With how much risk I can withstand. Let's say if you see that in your mobile phone itself, you have a security scan, correct? So there is a provision that you may run every day, every minute, every singular security scan. But you have seen that sometimes we have seen that when 21 days over, it is showing red flag and you are having immediate scan. That means you have that risk appetite, that much of risk you can accommodate within your system. Beyond that it is, you may call it as a vulnerable risk or something like to that effect. So if you see today's cyber crime, most of the cyber crime happens because of our risk appetite is not so easy. Working with cybercrime for so long time, and now every day you have seen at least 2 digital arrests, 1 cyber fraud, or a news regarding anything related to cyber crime is coming out daily in the newspaper. So working with that, I have understood that there are 2 things for which cybercrime is happening. One is need, another is greed. So threat actors are actually capitalizing the need and greed of the normal citizens, and they try to find out and creating kinds of, what do you say, different kinds of offers. They are offering you different kinds of things, and they are making you basically doing this for this. So what I have to do, I have to go nowadays what I am doing, I am allowing somebody to connect to my network. I am scanning him and allowing him to go to it. Now what I will do, I will scan the entire pathway through a CCTV monitor that who is coming, and generate an alert from the CCTV itself to the gate security that the person is coming may be suspicious. Then the right of checking or the level of checking will got increased, and they will check accordingly and go beyond that. So you have to manage the exposure accordingly. Why you manage exposure? You have to manage your assets exposure, your application and infrastructure. You have to manage the risk prioritization. You have to do the risk prioritization. You have to give a very holistic view to that. You have to do a preemptive mitigation to that. You have to complement device native security tools for that. So exposure management is required because your application, infra, and everything, whatever you say, so that all will go basically along with your system, and anything and everything with respect to assets, with respect to infrastructure, and with respect to anything, whatever you call it. So everything is now prone to the attack. And now you have seen that as much of attack is happening, all the attacks are happening with respect to the what you call the normal citizen, these that attacks is happening. Attack is not happening with respect to critical infrastructure itself. It will basically held critical structure infrastructure responsible for. Anybody has any idea about the critical information infrastructure in the state? Hello? Has anybody any idea about the critical information infrastructure in the state? Anyone? Sir, kindly give us at least one or two reply, as I have to also take the feedback from the participant that how it
No,
will
sir.
be going.
No, sir.
Nobody has any idea about the critical information infrastructure. So critical information infrastructure is the infrastructure which happens to be now managing identified critical information ecosystem of the country. Like if you see the power supply, it's a critical information infrastructure. If you see the hospitals, it's a critical information infrastructure. If you see the oil or petroleum machineries, if you see the banks, these are all critical information infrastructure. Now, as you've seen, the number of attacks is day in, day out. These are mostly related to citizen-centric attack. Citizen-centric attack can only lead to the loss of reputation, the loss of defamation, the loss of what you call the loss of money. So this much loss a cyber attack now can actually able to penetrate. But with respect to CII attack, if any CII attack launches, then it will basically take lives of the people. If one hospital infrastructure, if one electricity infrastructure, because nowadays everything is automation, everything under automation, and everything is controlled, maybe through SCADA, maybe through some other system. In case of a health, it is a ICD-10 ecosystem. In whatever form, the information ecosystem is going around the country and going around the states, everywhere, and all is digitally connected. And if you launch an attack over that network and able to stop a city's entire electricity out of it, then you have to understand that the amount of damage incurred in the city, and you will be surprised to know that the in case of every attack, before the attack, the attackers basically do a reiki over the entire ecosystem, to finding out that what types and what kinds of. Why I am telling that artificial intelligence is important here? Because it is not possible for a security system if because you have to understand that any security system works over the intelligence. So human intelligence, through the human intelligence, it is not possible to find out the area or find out the basically the building blocks of the ecosystem through which actually you will be able to get this. You have to use the artificial intelligence models in different area. In different models, I will just after finishing this slide, I will show you one write-up generated by me on your lecture itself. That's write-up. That's in the write-up form. Why I am coming into this exposure management? Because this is a typical area where the AI is very, very important. So I will show you one document. Now, I'm just stopping. You just remember this line CTEM. I will come back on CTEM. Just I am showing you. For that, I am showing you one document which is These are the probable area where you can use artificial intelligence. One is threat detection and prediction. Is it visible? Then is automated incident response. So AI can help to automate incident responses and identify threat, reducing the time between. Because you have seen that. Why I'm telling this? Because that continuous threat exposure management will lead you to this story. Because AI helps to automate responses. You just go through this document. Use a automated incident response. The enhanced malware detection, the area where AI can be used to make the system more cyber resilient. The phishing prevention, you can use NLP. The AI in vulnerability management, which I had already talked about. The AI use of AI in fraud detection, use of AI in cyber intelligence, use of AI in proactive defenses. I'm telling you. So these are the common area to get this system called, I'm showing you what you call the what you call the continuous threat exposure management. Continuous threat exposure management is actually, if you going through all of these processes, as I have shown you, these are the basic building processes, which is building these slides itself. So these are the process. If you see use of artificial intelligence in each of these processes, will basically give you an area of continuous threat exposure management, monitoring, adaptation, threat intelligence, mapping, come mitigation. So continuous threat exposure management is required to use of AI for making it cyber resilient. So these are the ports mostly used by the hackers. So these are the ports you may already aware of. These are the API databases, input forms. It is the security of application programming interface, which basically used by different components. The database, you have to evaluating security of the database connection, data storage, and this mechanism. Use input forms. These are security over exposure over the endpoints. You have to see that encryption attack is required. Encryption attack has been done, the SQL injection attack, and these are other some potential services. So basically, if you see, so this is all about the exposure management from my side with respect to the use of artificial intelligence itself. Now, if we have to go details into it, the use of the AI in the cyber security phenomena, I have to take a case, take a case study one by one, and I have to find out with some of the challenges, or you say what you can say, some of the issues coming out with that that currently, because we are closely working with the West Bengal Police. West Bengal Police and Kolkata Police, we are closely working with respect to different kinds of threat intelligence gathering, threat intelligence monitoring with respect to the cyber security network. We are using AI in our center. We have recruited some of the interns, which we recruit every year, twice in every year. Your college students, you itself can also be able to participate in that. But before that, you have to understand, before that, why we have created this kind of ecosystem for the state itself, because the professors, the lecturers, whosoever using this ecosystem with respect to artificial intelligence based system, you have to understand that the work of the government, the work of ours is to identify the skill gap and give you the right kind of pathway so that you can also be able to find out, come out with a solution. I would request the faculties and the research scholars who have joined this faculty development program that they might, because use of AI in cyber security could not be covered in a single lecture. I have just talked about the exposure management, which encompasses mostly all the services nearly which I have shown you in use of AI in the cyber security. Because use of AI in cyber security is a very, very huge field. But my request is that the professors and lecturers, those who are here, those who are continuously working with this kind of, by working with last 7 to 10 years in cybersecurity, I have seen that the cyber crime pattern changes year on year. Cyber crime type changes year on year. Cyber crime damages changes year on year. So I would like to request all of you that please try to find out some common areas, some areas of mutual interest, both between you and us, so that we can create an ecosystem. I am giving an open offer to all the faculties member present here, because we need a definite kind of research path. We need a definite, because what AI research has been done till date using cybersecurity, all with respect to analyzing data, finding out patterns, and some kind of helping the system to find out that. We have to go beyond that. We have to manage exposure, how to collect data out of it. Who gives you the data for doing this research? Then the government is here to give you the data to doing this research. If you institute as a collaboration, as a tie-up with us, so that we can go this kind of joint research with your team and promote this kind of ecosystem for the benefit of the states and the country in India. Right. So my idea, my submission to all of you is that exposure over the internet, securing exposure over the internet using the AI, that might be my current topics. That will help you. Maybe some I could be able to give you some sorts of insights which might help you in understanding the entire ecosystem. But you have to understand that how cyber attackers work, how cyber crime happens, how you have to make it, by way you have to make cyber resilient. The cyber resilient word is for the OEM, for a product development company is something different. For a software development company is something different. For government, it is something different. So there are different stages of understanding that how and why you are making it cyber resilient. So you pick up one area out of it. Your area is, as I have already told you, that your area is capacity building and do the horizontal research of our part. So for the capacity building, try to find out the area where you can use AI in cybersecurity, offer the internship program to the students, make small work group. We are allowing an internship in our Center of Excellence in Data Science and Machine Learning, where the students are paid for 3 months and 6 months internship. Sometimes it is free also. So my request is to all of you that try to identify some good problem statement for use of really good, which will be really good for the state. Because you have to understand, for formulating a problem statements, you know that the entire state network is open for you itself. Because you have to, if you have to place a small software engine over the network, I'm just giving you one example. That recently one of our team of interns came out with a solution that is a requirement of the government department using AI itself. So that's a those who are the resident of West Bengal or maybe some other states, because maybe here participants from other states also there. In each and every state, we are running many different schemes in the states, correct? But whosoever residing in West Bengal has any idea that for which scheme you are eligible? Anybody has any answer? Have you any idea? That for which government scheme you are eligible? I hope you don't have any idea that for which government scheme you are eligible. So we launched or we created AI applications using a huge amount of scheme data that if somebody comes to the system and asks that, it's a simply RAG model, comes to the system and asks the system that his system will ask some question to him that what is your eligibility, what is your age, what is your date of birth, what is your family type, and something like that. And it calculates the schemes for you and guiding you to apply to the schemes. So use of AI, I am making a proactive governance to my citizen. That's when it is a use of the citizen that I am enabling my citizen for applying for these schemes to avail these schemes through by the use of AI. My idea is that if somebody from your team or somebody from your work group or somebody from some other side formulate some application problem for securing exposure over the internet by using AI, you just come out to reach to us. We will definitely try to help you out by providing our resources, infrastructure, manpower, whatsoever is formed, and we will try to get it done. Correct. And now, anybody has any query on that? Because I have finished from my side. Anybody have any question on that? Just a second.
Any question from participant? I think there is no question from participant. So I have a small question, sir. Regarding AI application in cyber security, is there any specific pilot project by Government of India or our state government where cyber security related problem can be detected with the help of AI application?
From our, I cannot comment on the union government projects, but our state per se, we have not initiated any such pilot project on that. But yes, we are working on. That is why I am asking you that submit some kind of proposal to us which is feasible. So if anything, collaborative research project can be taken up by any of the institute, because we have a committee, we have some amount of the research part of it. So we can do this kind of work. From our state government side, we initiated a project 2 years back, which has finished, out of which the outcome is the secure coding practice framework, where some fund was given to it. 2 MTech interns were engaged to it for 1 year onwards. So they did a thorough research on the you must have heard of the West Bengal State Data Center, where nearly more than 1,500 government applications are resides. So with the security audit data of all those government applications, we have created a database, and out of the database, we run a natural language processing query, and we find out that what are the common patterns of mistake made by the programmers. And then we created a program called Secure Coding Practice Framework, from which is got approved by the certain thereafter and completed it. Yes, Professor Bharman.
Okay, thank you, sir. And is there any scope of a project? That means, is there any scope of a financial support from state government where we can submit proposal for cyber security, just like related to detection of cyber bullying in Bengali language, or whatever the commenting or cyber bullying happening in social media or any other network, such that we can initiate a project in our institute level. Is there any scope, sir, where we can get financial assistance from WebL or state government?
Yes, we have to understand that we are in the Department of Information Technology and Electronics. Information Technology Electronics rules of business does not allow us to do any kind of research work. How we can help your project? You have to understand that providing fund to a research project is the prerogative of the Higher Education Department, under which you all are employed, because that is the department which here to promote the research and education in the state. That is their business. But how we can help your projects? What we have created, we have support your projects. If you initiate this kind of projects, and as the COE created in our case, and if the outcome is beneficial for the state, if project review committee will give clearance on that, then what we can do, we can support your projects by allowing us infrastructure, which has a cost to the project. We can allow you maybe giving some, some amount of cloud. We can allow you for giving some, use the facility of our COE for doing this project. Allow you to any fund for, as you are doing in case of MITI and DT. But one thing we can do definitely from WebL side, that if you have any solid plan of any of you have any plan of which can be funded by MITI itself, so that kind of project we can submit to MITI, because MITI has a fund of research and development, separate fund. Our state government IT department do not have any separate fund. Our fund channelizes through by creating the Center of Excellences and infrastructure. That is how we support the R&D projects. Recently, we are supporting four projects in University of Calcutta also by providing the infrastructure and the other supports to the projects. One project in CSE also. So that is a you may call the in-kind contribution to the project with a financial commitment to the projects. But if you have to work with a joint projects with WebL itself, if the projects has got a commercial value, then we might approach IT department or MITI, Government of India, for some kind of fund. We can explore. Definitely we can explore.
That is also good service. Mainly if you provide infrastructure or different types of resources to make some collaboration with the academy institute.
Yes, that we can.
Engineering college. There are maximum participants from different engineering college, and faculty members are doing their research work. And in research work, there are different types of requirements. The initial requirement is we need some data. And I think you have sufficient data, you have the privilege to access those data.
Yes.
But we have some limitations to access those data.
Yes,
in
I know.
That case, I think we can collaborate with your organization to make some joint research work this way.
Professor
Without
Bharman, Professor Bharman, sorry to interrupt, that last month only, I was giving a talk on India AI Summit in Bangalore, where I have opened up a discussion on the different stakeholders of the IT in India, that we should create a policy for sharing open data, at least with the academic institution who are doing the AI research. Because I have seen that in our COE, one organization working with an institute called ATAL, you must be aware of, that is an Agricultural Training Research Institute. They are doing a projects. They are doing a projects on the soil health identification and the soil disease identification, correct? And plant disease identification. I'm extremely sorry, the plant disease identification. But they have collected the data of only 100 images of soil, and they break their heads to collect data 100 images of soil and 100 images of what you called the plant health, to analyze and reach to a correctness of 99%. In another startup which is in Bangalore, they are working in a project which is maybe kind of some other projects. They are using another 1,000 data or the 500 data with that. We should need a common grid where the data will be shared. I have opened up the discussion. The discussion is now taking at a serious level. That seriously, because we are very restrictive, as you must be all aware of the DPDP Act now in place, correct? With the invent of DPDP Act, correct? The data privacy and the data security is a call of the day, correct? So with the invent of data security and the data privacy, I will request all of you to kindly start a program with your institute immediately on the need and understanding of the data security and the data privacy in the system. Yes, Professor Chakraborty wants to say something. Yes, Professor Chakraborty.
Thank you, sir. I am Tamusha Chakraborty from Holdia Institute of Technology. Sir, first of all, thank you for the wonderful presentation and this knowledge sharing. Sir, I don't have any question. I just want to know, sir, can you please share your email ID so that the discussion you have just done now, that for any collaboration and for any data sharing or any kind of project we have, we can take some I guess some cloud space or some assistance from Weibull, so that we can discuss those things.
Madam, already given in chat box.
Thank you so much, sir.
And also, I don't have to follow any data privacy. I'm sharing.
This is excellent, sir.
So you because it's a academic interest of the state itself. So you are all, we are all working in the government for the benefit of the state itself. In anything and everything you need, just give me a WhatsApp. I most of the times I may not be. Please pardon me. I may not be take up your call at the right point in time. I may be or may not be. So just give me a WhatsApp, sir. This is a discussion that how can we initiate. I will get you connect to the right people. Then you talk to them. Realize that at least you will know the procedure and processes.
Right, sir. Right. So any other query from participants? So Kaushik sir, you have shared your mail ID, your phone number, and I think this is out of DPDC Act 2023.
Yes, it is out
We
of.
don't have any responsibility regarding your data privacy.
Mr. Mitra wants to say something, Professor Mitra. Yes, Professor Mitra, you can.
Hello.
Yes.
Sir. It's a very nice and nice session, and we learned a lot of knowledge from your end, because I am from mechanical engineering department, but
Yes.
I gathered a very good idea out of your session. Thank you very much, sir.
Thank you. Thank you, Professor Mitra. I would personally like to request you, all of you, one thing, that you have to understand that in recent day, in our state, some of the IT, ITES, and other initiatives are taking place. You have to understand that to keep pace with, as I am now serving the IT, ITES part of the state, I can tell only the IT, ITES part of the state. I may not be so acquainted with the manufacturing in other part of the state. So there is a need of the right finishing school in the state. Correct? You have to understand that whenever the students are passing out from any of the engineering college, I am by virtue of my post, I happen to be member of the many government interview board and committees. I've seen that in most of the cases, the students, those who are coming from the good engineering colleges also, they have just finished their curriculum. You have to see. I'm not blaming any professors. I'm not any complaining. I'm just trying to give you an idea on that. That if you have to make the future of the students of the Bengal in a good shape, you have to add some kind of good internship module to your program. May not be by ICT, by yourself. You have to curate some good projects. You have to get associated with institute like ours. You have to find out some areas. We are happy to help that. I'm telling you. I don't know how many of you are from the private engineering colleges. How many of you from the government engineering colleges? Recently, two of the I will not name. Recently, two prominent private universities of the state came forward to the IT department. They collaborated with us. They are giving their entire, we don't have such capacity. They are giving our entire students, those who are completing fourth year IT and computer science and BTech in artificial intelligence, all to us on the 7th semester onward, so that we can train them and make them ready for the industry. How it could be happen? So we are curating a very beautiful program called a career-linked incentive, career-linked internship program. You can also build. I'm not promoting my program. What I will say that you can also build similar kind of program to in your college itself. How we can do it? You just create a 6 months plan. First 3 months, you train a batch of students in a particular technology. Whatever you taught them for the last 3.5 years, just forget about it. So that you also know that there will be no use by the industry. So you have to find out one industry required skill in discussion with some of your some of your recruiting agency or something like that. What skill they need, correct? So you may get in touch with us. We may help you in developing some of the skills. Say they require VAPT skill. They require some DevOps programming skill. They require some kind of this skill, that skill. Identify 10, 12 skills like this. Group your students on that based on their inclination. Train them for the first 3 years. Place them in a live project. You'll be surprised to know that in an interview board, I've interviewed 31 candidates, and out of 31, you may be one of the engineering colleges. Out of 31 candidates did project on either on hospital management system or on hotel management system. No one did this project on their own. Everybody as a part of the team, because no one did this project. If you see the national education policy, in national education policy, the skill enhancement course from the very 3rd semester starts. So my point is that to make your students employable, besides the curriculum program, you also try to curate some these kinds of program. We have created many center of excellences on cyber security, on 3D printing. The one mechanical engineering professor told me we created the facility of 3D printing. You might be not aware of. We have created, which is a very much use of mechanical engineering students. So create a program on 3D printing, correct? Create a program on 3D printing. Create give them training for 3 days, and there are this kind of system, and then give them a live project which is available with us. then the students will be better placed in the industry. That's my submission to you. So to all the professors, those who are, with a due respect to everybody, so create this kind of module. Just get out of the syllabus, create this kind of the module and make it so we can help you to build this kind of module. It's out of nothing I'm saying, because I'm always interacting with teachers and professors. There are also many respected teachers and professors there. With due regards to everybody, so if somebody may be practicing, but if you are not practicing, because day to day, the way the industry looking into it, being a part of the IT and electronics industry, we are regularly interacting. You might have seen that today only. Why I am late? Because today only the Infosys second campus was the campus was inaugurated in West Bengal. I was part of this program. When I was coming back, I got stuck in a jam and I a bit late for the 2-3 minutes. So my point is that the Infosys is coming in the city. You have heard of Global Foundries is coming in the city. So there is a buzz around. The investments are coming. So we have to make our skill set ready for the industry. So for that, identify those skill gaps, find out those skill gaps, train your student on that. Maybe the syllabus will be there, the students will got passed, but find out the skill gap in maybe the mechanical engineering professor can find out the gaps in the mechanical engineering, in the industry and the course, and curate the course. Anywhere you support need, you just contact us. So that's my submission to you. I maybe sound something I am giving you some extra knowledge, but that's a submission from my side, because with a rare occurrence to interact with 150 odd professors in a forum. So thank you, Professor Borman, for arranging such a nice faculty development program. I don't know how much I develop you, but my idea is to give you some information so that because you are all knowledgeable, much more knowledgeable than me. I'm sharing my experience with you only to understand that the ecosystem.
Okay, thank you, sir. Thank you very much for your nice presentation. Actually, we have multiple types of speakers in this program. Few experts are from academic institutes and few are from industry. You and another experts from government sector. So it is a great opportunity for us or for all the participants to learn something about the current system or current scenario about the cyber security or cyber defense from the speaker like you. So thank you very much. I hope all the participants will be benefited from your experience you have shared with us, and you have already shared your mail ID, phone number, and I would like to request all the participants, if you think anything is required or is there any requirement, then you can directly contact with Mr. Haldar, and he is a nice person. He is very friendly in behavior, and thank you, Mr. Haldar, once again. Thank you, sir. Now, all the participants, we have launched 2 polls. Please respond.
May I leave?
Yes. Kaushikda. Yes.
Thank you.
Thank you.
Somebody wants to ask some question?
Yes, Professor Rajkumar. I think there is no question.
Okay.
Okay.
So I'm leaving. Thank you.
Yes,
Thank
sir.
you.
Thank you.
Sure.
Polls will be there for another 5 minutes. I would like to request all the participants Please respond.